Hello everyone. In this video, we are going to discuss how to convert infix expression to postfix expression, and also we'll discuss the algorithm. Then we'll discuss one example. Then we'll see that how it can be implemented in Python programming. So here, to discuss the algorithm, we consider one example here. That is a plus opening bracket b into c minus closing bracket d exponential e, then closing brackets, two closing brackets, and divided by f. So this example we will consider now here. So the concept is very simple. The algorithm for converting the infix to postfix is very simple. So first thing is, when we scan the given expression, if it is an operand, we'll directly push it onto the stack. And if it is an operator, we check the operator in the stack first. If the operator in the stack is having higher precedence than the operator that is scanned now, then we pop out the higher precedence operator from the stack and we add it to the postfix expression. Then, if the scan character is a opening parenthesis, then what do? We directly push it onto the stack. And the next possible thing is, if the scanned character is a closing parenthesis. So if the scan character is a closing parenthesis, we pop out the elements from the stack and we append it to the postfix expression until we encounter a opening parenthesis. So finally, after scanning everything, we pop out the content from the stack and append it to the postfix expression. That will give the resultant postfix expression over here. So now let us consider this example, that expression a plus and so on. So when we start scanning from the beginning, so the first thing character is going to be scanned here as A. A is an operand. So this operand will be directly sent to the postfix expression. And the next one is going to be a plus operator. If it's a plus operator, first we check, is there any content onto the stack? And if the content is having an operator, whether the operator precedence in the operator in the stack having higher precedence than the scanned operator, we will pop the content up from the stack until we encounter the lower precedence operator. Then we push the the scanned operator onto the stack. Now at present the stack is empty. So whatever the operator that we scan, that we will push it onto the stack now. So then that we have a plus over here. The plus is entered onto the stack. Now we encounter the next scanned character that's going to be a opening bracket. If it is a opening bracket, what we have to do? We have to directly push it onto the stack. So the stack content is getting incremented. And the next one is the operand B. So as we do the operand B directly, it's going to be entered onto the postfix expression. Next comes the operator, or the to be scanned character is an operator, that is multiplication. So now let us check the stack content, whether the stack is having any operator immediately, and whether the precedence of the operator is higher than the scanned character. Now when you look into it, no, there is no operator at this moment. At this moment we have only the opening bracket. So directly we will push the operator onto the stack. Then we scan the next character, that is C. So the C is an operand, so directly will be moved on to the postfix expression. Then we have a minus operator. The minus operator, now we compare it with the stack content. Now, whether the stack is having precedence lesser than this one or greater, it's having an higher precedence operator. Now, the higher precedence operator will be moved out of the stack. It will be popped out of the stack and will be appended to the postfix expression. Then the character will be added. That is the scanned character, it's a scanned operator that is minus will be added to the stack. So from here, immediately that minus the multiplication is moved to the postfix expression. Then the minus is added to the stack. Then we have what a opening bracket. If you opening bracket, directly push it onto the stack. No other thing. Then the next scan character is going to be an operand. So this operand now it's going to be appended to the postfix expression. Then we have a exponential operator. Now if you look at the exponential operator, now the exponential operator is going to be checked with the stack content. Now with the stack content, what we have immediately is only the opening bracket. So now without popping out directly, we will move the exponential onto the stack. Then we have a closing bracket. If it's a closing bracket, what we have to do? We have to pop out the content of the stack until we encounter the opening bracket. Until we encounter the opening bracket, that opening bracket will be neglected. And whatever popping out will be appended to the postfix expression. So now what will happen here? So exponential is okay. So now the E is can, so that's there. And next, when in closing bracket, what will happen? It is moved that until the first opening bracket, it will be popped from the stack and appended to the postfix expression. So exponential is moved to the postfix expression. And the next what again? Again, it's going to be an closing bracket. So what will happen? Until the opening braces, it will until the opening parenthesis, it will pop, excluding the or neglecting the opening bracket, and that will be appended to the postfix expression. So minus is now come out. Then what comes here? After that, we are going to scan now division operator. Now the division operator is compared with the operator onto the stack. So the operator is having a lower precedence. So the division operator will be pushed onto the stack. So then the next scanned character is going to be F. So F is an operand. It will be moved to the postfix expression. And with that, the scanning is completed. Next, what we have to do, we have to pop the content from the stack. We have to empty the stack. One by one, we have to empty it. So first we will take the division out. Then we'll take the plus out. So that now the postfix expression will be AB star DE exponential minus F division plus. That will be the postfix expression over here. Now, how to implement a Python programming? How to implement this in a Python programming? Okay. So now, if you look into it, it's very simple. The same concept we will translate it here, but with some housekeeping operations. So we are going to make use of a stack. So the stack is already we have defined, and now the stack is going to be used, and it's all the related properties are going to be used here. So now we use one method function. The function is going to be used to convert. The application is going to be developed in the form of a function. It will convert the infix expression into the postfix expression. So we taken one argument in the form of a string. That is, the expression will be coming in the form of a string. And then next, what we do, we define a stack object. That is, st is the stack object. Then, in order to know the precedence, we have one dictionary over here. So, with the help of the dictionary, for a opening bracket, we set the key value as 1. And for a plus, we set the value 2, precedence value 2. For a minus, it's of same class. Okay. So it is given 2. And for a multiplication and a division, the values are set as 3. So which is the higher precedence? The 3 will be the always the higher precedence. Then lower precedence will be the 2 and the lowest precedence will be 1 over there. Then to build a postfix expression, we have used a postfix an empty list over here. After that, we start scanning the character, the scanning the character in the string, and the operands are collected here in this form here. Now, what is that? Generally, when you take in any expressions, the operands will be in the form of alphabets or in the form of numbers. So, let us say that either the operand in the form of alphabets or in the form of a character, we are just going to append it onto the postfix expression, isn't it? So, we are scanning the entire string one by one in sequence. And the first thing is, we are implementing the algorithm now. If the scan character is an operand, the operand may be alphabet or maybe a number. So, if the character in this or character in this another set, then the postfix expression will be built by appending the operand. Okay, that's first thing. And the second thing is, if the scan character is a, a opening bracket, if it's an opening bracket, then what do? We directly push that opening bracket onto the stack, onto the stack. Okay. Else if it is a closing bracket, if it is a closing bracket, what we have to do? We need to pop the content from the stack until we encounter a opening bracket, isn't it? So the conditions are implied here. That is st dot is underscore empty. So the stack should not be empty. When you want to pop, the stack should not be empty. And also we ensure that it going up to the character is equal to the opening bracket. If it is opening bracket, it will come out of the loop. Okay, as long as this condition is satisfied, we'll pop the content from the stack and will be appended onto the postfix expression. The postfix expression will be continued to be built. Then, in order to update the character every time, the whatever the character we are popping out, and that we are putting onto the character. So that popped character will be sent here, and that will be checked every time on the while loop execution. And finally, if that means the scan character is not an operand, the scan character is not a closing bracket, then the scan character is not an uh, opening bracket or closing bracket, then what will be the next option? The next option will be as simple, it is an operator. Now, if it is an operator, how to deal with that? First, what we need to do, we need to check the precedence of the operator, the precedence of the operator in the stack. If it is having greater precedence than the scanned character, then we have to pop the content, isn't it? So that's what we do it here. So we ensure that stack is not empty, and also we continue to do all the precedence, all the operators which is having higher precedence, all the operators in the stack that's having higher precedence than the precedence of the scan character. Okay, so until satisfying this condition, we pop every content from the stack and append it onto the postfix expression. Okay, then finally we will push whatever the content that we have scanned onto the stack. So that is the operator. After removing all the higher precedence operator, we will push the lower precedence operator now onto the stack. Okay, so that we have pushed it out over to the stack. So this operation continues. This is the algorithm that we use for converting infix to postfix. And the next thing what we have to do at the end after scanning the entire string, what we have to do. So by this time itself, while doing implementing the algorithm itself, we will be pushing, popping, all these things we will do. But at the end, what we need to do, we need to completely, we need to empty the stack. So until the stack is empty, we have to pop the content from the stack and append it onto the postfix expression. So that will give us the resultant postfix expression, which is including the last value that we have stored onto the stack also. So everything will be taken out and that will build a good postfix expression for us. So that is going to be returned as a uh, value as a resultant postfix expression for this given function. Now, some of the examples also are given here. So we can use the I2P function by passing a string onto it. And now here we uh, find the resultant postfix expression that is resultant from the program. So any examples can be used here and the values can be tested. So such a easier method to convert the infix expression into the postfix expression. Thank you.